Okay. Solving trigonometric equations. Title of what you should put in your notes real quick. It's no longer on page 454. And today is December 4th. Correct?
Mm-hmm.
Maybe?
Yeah, page 4.
And it's still 2012 for a little bit longer. Solving trigonometric equations. How well do you guys remember your unit circle?
Well, that's part of that.
Okay.
What parts of the
And how well do you remember your algebra?
pretty good.
Okay. Calculus was doing this on the board, so this should look familiar. We'll go to some examples here. First example is sine x cosine x minus 1/2 cosine x equals 0. If you were solving this as an algebra equation, like xy minus 1/2 y equals 0, if you were solving that, what might be a good first step?
To take out the common thing.
Factor is the word you're looking for. Yes, take out the common factor. So you'd get y and x minus 1/2 when you were done, correct? Okay? When you have multiple factors, and once it's in parentheses, it's just one factor as far as you're concerned. Once you have multiple factors, you solve it by setting each factor equal to 0. So this is y equals 0, and x minus 1/2 equals 0, which I hope you could solve to x equals 1/2. Follow that pattern over here, and now my common factor is a cosine. So I take a cosine x out of both terms, and this gives me the two solutions of cosine x, or the two factored equations, I should say, equals 0, and also sine x minus 1/2 equals 0. Set each factor equal to 0 separately.
Yeah, but then how do you solve?
When does cosine equal 0?
It's
90.
it's 90 or 270.
90 or 270. When does the sine of x equal 1/2? And just stick to 0 to 360 now for these answers.
Equals 1/2.
Yeah,
Sine.
cosine 60.
30.
Sine x equals 1/2.
Yeah, when x equals 30. And where else? There's a positive 1/2, one other quadrant on the unit circle with a reference angle of 30. 150. So between 0 and 360 degrees, this equation has 4 solutions. If we stuck with x's and y's, we would just get the solutions of y equals 0 and x equals 1/2. Put in the trig, and cosine equals 0 when the angle is 90 or 270. Sine equals 1/2 when the angle is 30 or 150. And for tonight's homework, stick to 0 to 360 degrees. We'll talk about other possibilities soon. Any questions on this? You had to remember your algebra factoring trick here first. I'm going to do one more example.
How come,
And that's the answer?
how come you have sine? You put sine in for x and cosine for y.
Oh, good lord, if I was trying to be consistent, I really should have done that the other way, right? It could have been A or B. I was just completely grabbing two variables to stand for either of these. But you're right, I should have made it y to sine and x to cosine to keep me consistent. That was an unnecessary bit of confusion. Or I should have just used A and B or P and Q or something. Well, I needed the space for one thing.
And you know if you could be talking about it, you know.
No, but that's a good point. Plus now it bothered me because Robbie was right. I used the x and y backwards for how I say to you guys to think about it. Okay, there's another one real quick. Cosine squared x minus cosine x plus 1 equals sine squared x. Here's a hint. It can be very hard to solve one of these if you have more than one trigonometric ratio involved. In your perfect world, you'd like it to be all sines, all cosines, all tangents, all cosecants, all secants, or all cotangents. You want it to be all one thing. Here we didn't have that choice, but notice what we did. When we factored out the cosine, it gave us one equation with just a cosine in it, and another equation with just a sine in it. That's not going to help us here. I'm going to give you this one just because we're short on time. Normally I'd like to hear what your guys' ideas are, but the simplest way for this particular one, and here's where two things come in. One, you have to remember every identity we've ever looked at, and two, you got to develop some judgment that only comes with practice with these. Yes, sir. What's your idea?
Sine squared x.
And do what to it?
Negative 1 minus cosine squared x.
Perfect. Exactly what I was going to do. So the cosine squared x minus cosine x plus 1, you can change the sine squared x to 1 minus cosine squared x by rearranging your Pythagorean identity that sine squared plus cosine squared equals 1. Why try and get rid of the sine squared and not the cosine squared?
Because now they're all the same.
Now they're all the same, but what would have messed you up? And here's that judgment I was talking about. You either already have it or got lucky, Trey. Don't really care which. Both are great things in life. If you had tried to change the cosine to sines instead, you could have easily changed cosine squared to 1 minus sine squared. Is there an easy way to change cosine without a squared into sine?
No.
No, it's horrible. You could have done a displacement identity because, you know, if you shift, remember if you shift the graph 90 degrees, you could have put something in with x and then used a sum and difference. Oh my God, there's no good way. All right, so because there was only a sine squared over here and no sine, it was easiest to change this side. A term that's squared, a term that's not, a number. I'm going to add cosine squared x to both sides. And
Add. Wait, no, never mind. The one's not going to
well, I can subtract 1 from both sides and just forget about it, right?
Yeah.
So this is going to get me 2 cosine squared x minus cosine x equals 0. It's like a quadratic. It's like 2x squared minus x.
You take out the cosine x.
Yeah, bingo. Careful here. Do not move the cosine to the other side or divide everything by cosine. You will lose answers. Factor out a cosine x, and you're left with 2 cosine x minus 1 equals 0. The reason why it would have been very bad to divide everything by cosine or move this cosine to the other side and then divide both sides by cosine is you would lose a whole set of answers, because now our two sets of answers are cosine x equals 0, this factor equal to 0. I set the other factor equal to 0, and I get 2 cosine x minus 1 equals 0, which is the same as cosine x equals positive 1/2. Once again, at what angles between 0 and 360 does the cosine equal 0? When is this true, in other words? I know I went a little fast
Is
there.
that true?
We already did it over here.
Right, it's at 90 and 270.
Excellent. When is cosine equal to 1/2?
60 degrees and,
120.
no, it's
Or no,
120
no,
would- no,
that'd
it's
be negative.
300 degrees.
Yeah.
300 degrees. Very good, because a positive cosine only occurs in quadrants 1 and 4 with a 60-degree reference angle. Okay, ignore the directions for tonight for the equations I've assigned, which is page 459. 18 to 28, let me double check that. 18 to 28 even. Find all the answers between 0 and 360. I don't think that's what the directions say, but that's what I want you to do with those equations. Does that make sense?
Yeah.
Excellent, you guys were awesome today, and we barely made it to the end.